Good morning. Today our new class is pinout diagram of IC 741 and characteristics of ideal and practical op-amp. So pinout diagram of IC 741 and another topic is characteristics of ideal and practical operational amplifier. Okay, these two topics one by one discussing now today class. Okay, and next recap of this presentation. In previous class we discussed about important specifications of operational amplifier IC 741. So in previous class we can discuss about different important specifications of operational amplifier IC 741. Okay, next objectives of this presentation. On completion of this period you would be able to understand. So first one is pinout diagram of IC 741 and second one is characteristics of ideal and practical operational amplifier. Characteristics of ideal and practical operational amplifier and also summary. These topics one by one discussing now today class. Okay. First of all, in these topics, first topic is pinout diagram of IC 741. Pinout diagram of IC 741. A very popular IC version of op-amp is, op-amp means operational amplifier. A very popular IC means integrated chip. IC means integrated chip. A very popular IC version of op-amp is microampere 741. It is the very popular IC version of op-amp, that is microampere 741. Okay, the manufacturer, different manufacturers are defined these IC 741 and identify the different names. Okay, the manufacturer of microampere 741 is Fairchild Semiconductor. In Fairchild Semiconductor industry, the manufacturer of microampere 741 name is Azane. Okay, next the number of other manufacturers, also produced IC 741 op-amp. The number of other manufacturers also produced IC 741 op-amp version, namely MCI 741 by Motorola, LM74 by National Semiconductor, etc. Okay, first of all, so IC version, a very popular IC version of op-amp is microampere 741. So this name included by Fairchild Semiconductor manufacturer. Okay, so number of other manufacturers also produced by IC 741 op-amp version, namely MCI 741 by Motorola, LM741 by National Semiconductor, etc. For convenience, this widely used op-amp IC is called simply IC 741 op-amp, dropping the prefixes. Okay, for convenience, this widely used op-amp IC is called simply IC 741 op-amp, dropping the prefixes. Okay, next, pin configuration of IC 741. Pin configuration of IC 741. Observe this. This is the pin diagram of IC 741 op-amp. This is the pin diagram of IC 741 op-amp. Okay, so this is pin configuration of IC 741. IC 741 pin configuration. So the most commonly used op-amp is IC 741. The most commonly used op-amp is IC 741. So the IC 741 op-amp is a voltage amplifier. It is a voltage amplifier. It inverts the input voltage at the output. It inverts the input voltage at the output. It can be found almost everywhere in electronic circuits. It can be found almost everywhere in electronic circuits. Okay, I repeat this point again. Pin configuration. First of all, the most commonly used op-amp is IC741. So this IC741 op-amp is a voltage amplifier. It inverts the input voltage at the output. It inverts the input voltage at the output. It can be found almost everywhere in electronic circuits. It can be found almost everywhere in electronic circuits. Okay. And next, there are many common application circuits. There are many common application circuits using IC741 op-amp. There are many common application circuits using IC741 op-amp. They are adder, comparator, subtractor, integrator, differentiator and voltage follower. Okay, I repeat this point again. There are many common application circuits using IC741 op-amp. So these are adder, comparator, subtractor, integrator, differentiator and voltage follower. Okay, next, the IC741 is a 8-pin IC available in dual inline package. Dual inline means both sides or connections are made. Okay, so the IC741 is a 8-pin IC. Okay, in this IC is available in dual inline package, DIP means dual inline package. So this IC available in dual inline package. See this pin diagram of IC741 op-amp. So this is the op-amp. It is a 8-pin dual inline package with a pinout. It is a 8-pin dual inline package with a pinout shown above. Okay, so observe this pin. So pin 1 is offset null. Pin 1 is the offset null. So in this IC, pin 1 is connected offset null and pin 2 is connected inverting input terminal. Pin 2 is connected inverting input terminal of operational amplifier IC741. Okay, so next, pin 3 is nothing but non-inverting input terminal of operational amplifier IC741. Pin 3 is nothing but non-inverting input terminal of operational amplifier IC741. So what about pin 4? Pin 4 is nothing but negative supply voltage. Pin 4 is nothing but negative supply voltage. It is voltage. So it connected negative supply voltage minus VEE. And what about pin 5? Pin 5 also same as pin 1. This is offset null also. Okay, so what about pin 6? It is connected to output voltage. Pin 6 is connected to output voltage. So what about pin 7? Pin 7 is connected to positive supply voltage. Pin 7 is connected to, it is also a voltage. Pin 7 is connected to positive supply voltage. Positive supply voltage is nothing but plus VCC. And last pin 8 is nothing but there is no connection. So because why it is connected? So this is supporting pin. This is using for the purpose of balancing. Okay, so these are one by one these pins description of op-amp 74 IC1 is discussing one by one. Okay, the description of op-amp 74 IC pins. Okay, so first of all, pin 1 and pin 5. Pin 1 and pin 5, both pins are used for offset null. Okay, pin 1 and pin 5, these two pins are used for offset process. What about pin 2? So pin 2 is connected to inverting input terminal of operational amplifier IC741. What is pin 2? Pin 2 is connected inverting input terminal of operational amplifier IC741. That is, when a sinusoidal signal, that is the sine wave, when a sinusoidal signal is applied to the input pin 2 waveform of different phase output is obtained. That is 180 degrees out of phase shift. That is 180 degrees out of phase shift. Okay, I repeat pin 2 again. Pin 2 is connected to inverting input terminal. That is, when a sinusoidal signal is applied to the input pin 2 waveform of different phase outputs is obtained. That is 180 degrees out of phase shift. 180 degrees out of phase shift. And next, pin 3. What about pin 3? So, pin 3 is connected to non-inverting input terminal of operational amplifier IC741. Pin 3 is nothing but non-inverting input terminal of operational amplifier IC741. That is, when a sinusoidal signal is applied to the input pin 3. When a sinusoidal signal is applied to the input pin 3, then the waveform of same phase output is obtained. Then the waveform of same phase output is obtained. Okay, this is nothing but pin 3. So, what about pin 4 of IC741 pin configuration? Pin 4 is connected to negative supply voltage. Pin 4 is connected to negative supply voltage minus VEE. So, that is negative terminal of supply voltage is connected to this pin. That is, the negative terminal of supply voltage is connected to this pin. Okay, and next, pin 4 is completed. What about pin 5? Pin 1 and pin 5. So, both are connected to offset null. Okay, and next, pin 6. Pin 6 is connected to output terminal. Pin 6 is connected to output terminal. And next, what about pin 7? Pin 7 is connected to positive supply voltage plus VCC. Pin 7 is connected to positive supply voltage plus VCC. That is, the positive terminal of supply voltage is connected to this pin. That is, the positive terminal of supply voltage is connected to this pin. And next, what about pin 8? There is no electrical connection to the pin 8. No electrical connection is there in this pin. Okay, so this pin is just for balanced symmetric dual input package. Look, this pin is just for balanced symmetric dual input package loop. Okay, so these are different pins and connecting which type of signal is connected to which type of pin. Okay, so this is nothing but pin configuration of IC741 op-amp. Okay, in this case, so differential mode gain, common mode gain. In this case, differential mode gain, common mode gain. So, what is the differential mode gain? It is the gain of the op-amp when the input signals are 180 degrees of the phase and exactly equal in amplitude. Differential mode gain is nothing but it is the gain of the op-amp when the input signals are 180 degrees, when the input signals are 180 degrees of the phase and exactly equal in amplitude. And what about common mode gain? So it is a gain of the op-amp. What about common mode gain? It is a gain of the op-amp when the input signals is in phase and exactly equal in amplitude. So what is the common mode gain? It is the gain of the op-amp when the input signals is in phase and exactly equal in amplitude Okay, these are different mode gain and common mode gain. Okay, this topic is completed. And next topic is characteristics of ideal op-amp. Characteristics of ideal op-amp. What are the characteristics of ideal op-amp? So different characteristics of ideal op-amp are, the first one is infinite voltage gain. Open loop voltage gain. This is nothing but infinite open loop voltage gain. So it is denoted by AOL. AOL is equal infinity. The infinite voltage gain, that is AOL is equal infinity. And next characteristics of ideal op-amp is, and next characteristics of ideal op-amp is input impedance is infinite. So the input impedance is denoted by R in, so it is infinite. Therefore R in is equal infinity. Therefore R in is equal infinity. And third characteristics of ideal op-amp is output impedance is 0. So output impedance is denoted by R naught. Output impedance is denoted by R naught. It is 0. Output impedance is 0. And fourth characteristics of ideal op-amp is, and fourth characteristics of ideal op-amp is offset voltage is 0. Offset voltage is denoted by V of, so that is equal 0. Therefore offset voltage is 0 in case of ideal operational amplifier. And next characteristics of ideal op-amp is nothing but bandwidth is infinite. Bandwidth is infinite. And CMRR also infinite. This is another characteristics of ideal op-amp. CMRR is also infinite. This is another ideal characteristics of op-amp. And next slew rate. Slew rate is infinite. Slew rate is infinite. And also the last characteristics of ideal op-amp is nothing but characteristics do not drift with temperature. Characteristics do not drift with temperature. These are different characteristics of ideal operational amplifier. In these characteristics all are infinite. Voltage gain, input impedance, bandwidth, CMRR, slew rate, all are infinite. Okay. And next offset voltage, output impedance are zeros. Offset voltage and output impedance are zeros. Okay. So and next these characteristics do not drift with temperature. These characteristics do not drift with temperatures. These are characteristics of ideal op-amp. And next characteristics of practical op-amp IC 741. Characteristics of practical op-amp IC 741. The first characteristics of practical op-amp is nothing but, so voltage is high. Voltage is high up to 2 into 10 to the power of 5. Voltage is high up to 2 into 10 to the power of 5 volts. Okay. So and next characteristics of practical op-amp is nothing but input impedance is high. What is the value of input impedance? 2 mega ohms. It is high. And the second important characteristics of practical op-amp IC 741 is nothing but input impedance is high up to 2 mega ohms. Okay. And next third characteristics of practical op-amp is nothing but output impedance is typically few hundred ohms. Output impedance is typically few hundred ohms. Okay. And next characteristics of practical op-amp IC 741 is nothing but input offset voltage is very low. What is the value of input offset voltage? It is very low up to 100 microvolts. It is very low up to 100 microvolts. Okay. And next CMRR. And next characteristic of practical op-amp is nothing but CMRR. CMRR is up to 90 decibels. In practical value of CMRR is nothing but 90 decibels. Okay. So practical characteristic of slew rate is up to 0.01 volts per microseconds. The slew rate is up to 0.01 volts per microseconds. And last characteristic of practical op-amp is nothing but bandwidth is up to 1 megahertz. Bandwidth is up to 1 megahertz. These are different characteristics of practical op-amp. Okay, I repeat once again. So practical op-amp, so the characteristics, first one, voltage gain is high, that is up to 2 into 10 to the power of 5 volts, and input impedance is high up to 2 mega ohms, and output impedance is typically few hundred ohms, and input offset voltage is very low up to 100 microvolts, and CMRR is up to 90 decibels, and slew rate is up to 0.01 volts per microseconds, and also bandwidth is up to 1 megahertz. H. Okay, these are important characteristics of practical op-amp. Okay, and next, characteristics of ideal op-amp and characteristics of practical op-amp are also completed. Okay, and next, summary of this presentation we have seen pinout diagram of IC741, pinout diagram of IC741, and characteristics of ideal and practical op-amp, Okay, so next, frequently asked questions may be asked. The first question is, state the ideal characteristics of an op-amp. And another question may also be asked in today topic is, second question is, state the practical characteristics of an op-amp. And another different question may also be asked in today topic is, draw the pinout diagram of IC741. And this question may also be asked in different ways. So briefly explain about pinout diagram of IC741 op-amp. So these questions, different type of questions may be asked in today topics. Okay, today topic is very important topic. Prepare well. Okay, any doubts? Okay, thank you.